Okay. Cool. So we're back. This is not the problem that I was on. Let's clear this out. Delete all this mess. Okay. So this. Okay, sorry about the stream cutting in and out. I'm not super sure what's going on, but there's something wrong with OBS that I cannot figure out. Okay. Okay, this is what we're after. So. And then, okay. So basically what we need to realize is that the handrail here, I guess if you're following me from the other stream, you kind of realize what's going on, but what we need to figure out is these angles, and it's important to realize that this handrail is perpendicular to the surface here of these kind of like this angle of the stairs. Or, I'm sorry, not perpendicular, parallel. And so the angle between this handrail this handrail is like a transversal for these perpendicular, these parallel lines. So let me draw this parallel line here. So this is parallel to this. And so we can use some of those theorems from geometry. Okay, let's see if we need them. I'm not even sure if we will. So we need to find alpha. Angle alpha is the angle between the walkway of and the horizontal, while angle beta, okay. And so all of these handrails are, they're making the same, or they're parallel to this diagonal side here. To this vertical side here. So they're all parallel to that. So this should also be a right angle here, because they're saying that the stairs make angle alpha with the horizontal, and that's a vertical line. So this is 90 degrees. Okay, so we know that alpha plus whatever this angle is over here, whatever this angle is over there, should be equal to alpha plus whatever that angle is should be equal to 90. Right? Those are the remaining two angles in a right triangle. This one's 90, and they all add up to 180. And let's see if we can show, I think that this guy here is beta. Let's see if we can show that. So, yeah, okay. So the way that we can do this directly is we'll say that this handrail here is parallel to this vertical angle. So right there. Okay, these are parallel lines. So the transversal is actually this line here, the surface of the stairs. And so when you have two parallel lines cut by a transversal, the alternate interior angles are congruent. So this is also beta. So that makes this beta here. All right, so let's see if we can walk through that. We have two parallel lines, these vertical lines, the one with the handrail and the kind of like backside of this big triangle. Those are parallel lines. Then this line here, the one that is kind of the surface of the stairs, is a transversal to those two parallel lines. This angle and this angle are alternate interior. They're inside the parallel lines on the alternate sides of the transversal. So we know that these two angles have the same measure, they're congruent, so we can make this relationship here. Okay, so then we actually know beta. It's given to us here. So I can substitute 56 degrees in for beta. And then I just solve for alpha by subtracting. So what will 34? Yeah, and so if you don't remember your geometry, you would probably not be able to solve this. I think that they're not asking for a proof. That's an important thing here. And if you are able to look at this and say, okay, this is probably to scale or like approximately to scale, and these are parallel lines, so it doesn't matter if it's to scale. I can tell that beta is equal to that angle. If you can just look at it and see it, just go with your gut, right? It's not about being able to prove everything all the time. Ideally, you would be able to, but if you can't, you can't. You know, you got to get your homework done. Okay. Let's go to the next one. All right. So this says solve for x in the following right triangle. Okay. So here we're given a right triangle and three sides. Anytime I see a right triangle, I'm thinking trig functions and Pythagorean theorem. Since I don't know any angles and I'm not asked to find an angle, I don't care about the angles between each other. I probably don't need to use my trig functions. That leaves me down to the Pythagorean theorem. So the Pythagorean theorem says that if you have a right triangle, okay, which we do here, you have a right triangle, you can call its legs A and B and its hypotenuse C. The sum of the squares of the legs of a right triangle are equal to the square of the hypotenuse, right? So in this triangle here, the hypotenuse is 13, and you could call this leg A and this leg B. Okay, so just by substituting into the Pythagorean theorem equation here, you'll get x squared plus x plus 1 squared equals root 13 squared. And let's see if we can solve this guy. So we get x squared. I'm going to FOIL this out. I'm just going to do it really quickly. So if you have questions about foiling, post it in the chat. Okay, so we'll get x squared plus 2x plus 1. If that's not clear, make sure you ask a question. And then root 13 squared means root 13 times root 13, which is 13. So when you square a square root, you just get the number underneath. Okay, so we can combine some like terms here. So we get 2x squared plus 2x plus 1 equals 13. And then I'm going to subtract 13 from both sides. Okay, so here I've got a quadratic, and this should give me two solutions. I should have two solutions to this quadratic equation here. One of them will be the solution that we're looking for. The other one will probably be like a negative number, and we'll have to throw that one out because we don't want a side length to be negative. But let's just see what comes out of this. I know that the solutions to this equation are the same as the solutions to this equation. I'm dividing both sides of this thing by 2. Okay, 0 divided by 2 is 0, and then obviously all of these coefficients here, 2, 2, and negative 12, they're all divisible by 2, so I just divided both sides of this equation by 2. These two equations have the same solutions. And then I can solve this by factoring, I think. Let's see. So the factors of 6 that we'll use are probably 2 and 3. And we just need to figure out which one's negative and which one's positive. So they should add up to be a positive number. So I want the positive number to be greater. And there you go. This is my my factorization. So let's take this up to here and work on it a little bit more. So by the zero product principle, right? And since I know the zero product principle exists, that's why I knew I wanted to factor this to solve. I know that either x minus 2 equals 0 or x plus 3 equals 0. And if we solve this, so solve by adding 2 to both sides, I get x equals 2 or x equals negative 3. Now let's think about this in context. So my side length here is x. I can't have a negative length. That doesn't make any sense. The negative kind of throws that off. So that means the negative 3 is actually a bad solution. That's junk. We're going to throw that away. So x really is going to equal 2. And if x equals 2, then x plus 1 equals 3. And there you have it. So let's actually check these. Let's check and see if it works. So 2 squared plus 3 squared should equal 13, right? Which is root 13 squared. So this is 4, this is 9, and they do in fact equal 13. So this looks good. So let's put x equals 2. And it's important to be careful what they're asking you to input for the answer is really important. Okay. Nice problem there. Those 3. All right. Let's do another. I'd like to be able to get through all these. Okay, consider the figure. Find AB if BC equals 3. Okay, so let's start labeling. BC equals 3, BD equals 5, and AD equals 2. Okay, so we want to find AB. That's this long side. So there's 2 triangles here. Let me see if I can highlight that. There's kind of this triangle, which goes here, here, and here. And then there's another triangle, which I'm going to just overlap this because it doesn't really matter. I'm just trying to show this for a second. I'll take these away after maybe. Here, here, and here. So there are 2 triangles. They share that angle. They're right triangles, both of them. So I think we can use that information. Then we're trying to find the hypotenuse. So let's see if we can find this segment here, DC. Let's call it X. Same thing. So since I have a right triangle, I can say by the exact same relationship as the last one, I can use the Pythagorean Theorem. I can say x squared, which is that side length I labeled DC, plus 3 squared, the other leg, is equal to the hypotenuse squared, 5 squared. And so we can just quickly solve for x squared. Let's go x squared. 3 squared is 9, and 5 squared is 25. Then we subtract 9 from both sides, and we get 16. And the square root of 16, all right, so we take the square root of both sides. Now here we want to get plus or minus the square root of 16. We always got to remember to do the plus or minus when we do a square root of 16. This is equal to plus or minus 4. Now, I'm saying to do that at the same time I'm about to say we're going to throw away that minus. Why? A side length can't be negative. Okay, so we're going to throw that away. That solution is junk, but it is a solution to that equation. So it's important to know that and develop the habit of writing both of those down and then evaluating to be if they're both possible solutions, just so you don't lose roots to these quadratic equations. Okay. All right, so now we know that side length AC, that's the full bottom side here of the bigger triangle. Side AC is 2 plus 6. That's by the segment addition postulate. Okay, so this full length here is 6. So let's actually break that out. We're going to get a big triangle. This is not going to be exactly the same. I'm going to try and do the best I can, but this is the kind of bigger triangle here. So, all right, let's go with it. So I took away this segment DB. So this now has sides 3, 6, and AB. Here, this is A, this is B, and this is C. So this side length, we already used X. Don't want to throw anybody off. So we're going to call this Y. we're going to use the exact same thing. We're going to use the Pythagorean theorem. So to figure this out, we're going to have 6 squared plus 3 squared equals y squared. Okay, so a squared plus b squared equals c squared. And let's see, so this is going to be 36 and 9 equals y squared, and this is 45 equals y squared. And then we take the square root of both sides, so we get y is plus or minus the square root of 45. And so 45 is 9 times 5. So this is plus or minus the square root of 9 times the square root of 5, which is equal to plus or minus 3 root 5. So typically with these like WebAssign, Pearson, whatever product you're using, Cognitive, they all are gonna tell you whether or not you want an exact value or round to some decimal point. Okay, if they don't tell you to round to a decimal point, you can be fairly certain that they want an exact value. So it's important that you actually simplify your square root this way and get down to the 3 root 5. If there's any question on how I did that, post it in the chat. Otherwise, we'll just keep it moving. So and again, I've said this a few times, we're going to throw away the negative. Side lengths of a triangle can't be negative. So we're just left with the positive 3 root 5. Okay, there it is. That's a good one. And where are we? Let's see what this next one is. Did I do this one already? Yeah, that's the one we just did. All right, so let's close that out. And get over to this one. Okay, find the remaining sides of the 45, 45, 90 triangle if the longest side is 9 root 2. Right, enter your answers as a comma separated list. So I always recommend drawing a diagram for these kind of problems just to orient yourself to the problem. It doesn't stand for proof. You can't really like use it, but a lot of times you'll get points if you draw this diagram. Even if you can't actually execute the problem all the way. If you can just set it up, this will help you to set it up, and your teacher might give you some points for this. Okay, so we have this 45, 45, 90 triangle. The longest side, the hypotenuse, is 9 root 2. Now, since these two angles are equal, their opposite sides are also equal. Okay, so let's just call them x. We can do the exact same thing that we've been doing. We can set up the Pythagorean theorem with this. We'll say x squared plus x squared equals 9 root 2 squared. Okay, so x squared plus x squared is 2x squared. And then 9 root 2 squared, we square the 9 and we get 81. And we square the root 2 and we get 2. So 81 times 2. Now I'm going to divide both sides by 2 here. I'll divide by 2, divide by 2. These 2's cancels and these 2's cancel. That's why I didn't even bother multiplying 81 by 2. It's not necessary. Oftentimes you can just leave things factored and save yourself a lot of trouble. Okay, so now you've got this x squared equals 81. You're going to take the square root of both sides. And this should be super easy because you just squared 9 to get 81. So you know that the square root of 81 is 9. So you get plus or minus 9. And again, we're going to throw out that negative answer since a length can't be negative. And they want us to enter our answers as a comma separated list. So find the remaining sides. And they could have just like entered one number here, but I think that would have given away that the side lengths are equal, and you actually needed to know that in order to solve this. So 9 comma 9 is how you're going to enter that problem if you were to come later and find this. Okay. So let me delete some stuff. And we'll do another one. That's all right. This will do. Coffee delivery service. Okay, a bullet is fired into the air at an angle of 45 degrees. How far does it travel before it is 1,000 feet above the ground? Okay. Assume that the bullet travels in a straight. Okay, assume that the bullet travels in a straight line, neglect the forces of gravity, and give your answer to the nearest way. Yeah. So the forces of gravity are negligible in this one. The bullet travels in a straight line, so we want it to be 45 degrees with the horizontal. Okay. And so we can draw a triangle. Like, how do I know I'm drawing a triangle? Like, how do I know this is what they're looking for? Well, this material is coming with a bunch of other triangle material, and they've given me the angle with, you know, this thing here. So I've got two sides. They told me that so let me actually maybe even change the color of this. So the bullet I'm going to do in red. So it's dangerous. Okay, here we go. So the bullet is going to travel in a straight line. That's what they've told us. And that straight line makes a 45-degree angle with the horizontal. And then the key here is how far does it travel before it is 1,000 feet above the ground? Okay, so if the horizontal is the ground, this is 1,000 feet. I need to know how long it takes before it gets that high. Okay. So that's how I was able to tell. Boom, 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 boom. How far does it travel before it is 1,000 feet above the ground? Okay, so I said this before, and I think it bears repeating. Anytime I recognize that this is a triangle problem, and I draw my triangle and I label all of the data that I know, I start thinking trig functions and Pythagorean theorem, and maybe you'll use both or like many of each within one triangle. So here I'm looking for this side, this unknown side here, and I can see that I have an angle, I have the opposite side, and I have the hypotenuse within a right triangle. And so if you write out your SOHCAHTOA mnemonic device, then you can see that we have an opposite and a hypotenuse. I should use the sine relationship. Okay, so I can write an equation, and I encourage you, don't try to like memorize all the different ways you can do solutions for these. Just like know the definitions of sine, cosine, and tangent, and then actually set up an equation. The sine of the angle that we know is equal to the opposite side divided by the hypotenuse. And so I just make this relationship. That's it. And from after I've got it on paper, that's when I start to worry about how to solve this thing. So I need to get the x in the numerator. So I'm going to multiply both sides by x, and I'm left with x times the sine of 45 degrees, which is equal to 1,000. And then I'm going to divide by the sine of 45. It's important to realize that this sine of 45, it's got letters in it, but these are not variables. This is hard to read because it's in function notation. And many of you who are encountering this material for your first time have only ever seen the function f, g, and maybe h, right? But these are the names of these functions, f, g, and h. And this is the name of the sine function, right? It's actually fully, if you were to really write it out, it's sine. But we abbreviate it with sin in the same way that we abbreviate cosine and tangent. So it's important to realize that this is a function. And when you plug in a value into a function, this whole thing just turns into some number, okay? So that number we can cancel here. And then so x is equal to 1,000 divided by sine of 45. Now I know from using my knowledge of trig and my unit circle, which is not something that you should be forced to memorize, it's actually a tool that can help you. I know from my trig knowledge here, my unit circle, that this point here on this triangle gives me 2 over 2 comma root 2 over 2. So the sine and the cosine of the angle 45 degrees are root 2 over 2. Okay. So 1,000 divided by root 2 over 2 is the same as 1,000 times the reciprocal, which is 2 over 2. And then we need to rationalize the denominator here. So I'm going to multiply by root 2 over 2. If there is any, root 2 over root 2. If there's any question on that, post it in the chat. But essentially, this is just 1 root 2 divided by root 2 is 1, and you can always multiply by 1. The reason why I'm doing it is it will change the way this fraction looks. It'll be an equivalent fraction. We're going to have 1,000 times 2 root 2. Root 2 times root 2 in the denominator becomes 2, and you'll see that these cancel. So our answer here is just 1,000 root 2. Oh, okay, so this is great. If you're paying attention to the instructions, the last little tidbit that they give us here is give your answer to the nearest foot. So with this, you actually know that you need to get an approximation for this root 2. So I'm going to go to my calculator. I just got this new calculator. This one's cool. It's cheaper than the TI 84 plus series and higher. And you can code on this thing with Python. So, and I've put this thing into degree mode. And so I'm going to do, so I'm going to actually enter the sine of 45, right? So I'm going to do 1,000 divided by the sine of 45 degrees. Sine. Let's try it. Okay, yeah, so that worked out. Yeah, cool. So yeah, plug that into your calculator and you get this value here. So we're going to enter that into this box. It's going to be to the nearest foot, 1414. Okay, feet. Don't type the feet. That's extra. And there you have it. All right, there are no questions on this. I'm going to keep going. No way I'm going to finish this. Okay, find all 6 trigonometric functions of theta if the given point is on the terminal side of theta. Okay. So what do we know? Those two. All right, so let's imagine that we have a coordinate plane here. And that on this coordinate plane, we have a circle. It's centered at the origin. Just pretend that this is centered. I don't know if it is or not. And so to find all 6 trigonometric functions of theta if the given point is on the terminal side of theta. So we have a point here, 0, -2. And so that point is going to be down here, 0, -2. Okay, so this point is on the terminal side of my angle. And that's good information. So I actually know that this angle, let's say it's in standard position, is right there. So let's color this thing so you can see the terminal side. All right, oops, there we go. Okay, yeah, that didn't really work out. But it doesn't need to be perfect. Okay, that's good enough. So here you go, you've got this side and of a terminal angle, and it opens, you know, counterclockwise in standard position, everything. So we need to figure out the sine, the cosine, and the tangent of this angle. Well, I can look at this and evaluate these things using my unit circle knowledge. So this is 270 degrees, or 3 pi over 2. So sine of this is -1. Sine is 0. Tangent is undefined. and it says to enter it like that. The cosecant. So cosecant is 1 over sine, and 1 over negative 1 is negative 1. And then the secant is 1 over cosine, and 1 over 0 is undefined. And then the cotangent is the cosine over the sine. So cosine is 0, sine is negative 1, 0 divided by negative 1 is 0. So this is pretty, like, this is a quick hitter. This is a thing that you should draw a picture and be like, oh, I know what that angle is. And then immediately be able to figure it all out. These layers, get rid of that. Let's do another. Making steady progress. I want to be able to get these all down. Okay, so this is interesting, actually. So this is the same kind of problem, but this actually expects you to have a little bit more mastery of the thing. This is kind of similar to the one that we had earlier, where it gave us an angle x, so we had to find the complement and the supplement. So it was all going to be in terms of x. This we're going to have in terms of a. So it says, find all 6 trigonometric functions of theta if the given point is on the terminal side of theta. So here's the given point. That given point is on the terminal side of an angle theta. So let me go through this whole rigmarole of drawing some axes again. Okay, here's some axes. Let's make it all right, that's good enough. And then what do we want? We want to plot this point negative 12a, negative 9a. So this is actually kind of difficult because we don't really know what a is. A could itself be a negative number, but let's just plot the point negative 12, negative 9 essentially. So we'll go negative 12, negative 9, something like here. Okay, and we'll call this point negative 12, negative 9. Sorry. A, negative 9a. Okay. So if we imagine that this thing is on a circle, imagine that this thing is on a circle, which is centered about the origin, something like that. This thing's kind of tough to do, actually. Work. I think this is pretty good. Let's call it right there. Okay, so if we imagine this thing is on a circle, and we have this angle in standard position, and then we could, make this triangle here. Just like that. And now we can use our trig knowledge to kind of like draw this thing up. So let's say that, change this, okay. The sine of this angle is going to be the opposite over the hypotenuse. So let's look at this. This is the x coordinate. That means that this is negative 12a. This distance from here to here is negative 12a. And this distance from there to there is negative 9a. Okay. I'm leaving the negative because I don't know if a is positive or negative. So it doesn't really matter for the sake of these like ratios, because the ratio will take care of the sign. So we can actually figure out what the hypotenuse is here. The hypotenuse of this triangle is going to be negative 9a squared plus negative 12a squared, which is equal to the hypotenuse squared. Okay. And so we can just square these things. We're going to get 81a squared plus 144a squared equals h squared. And then we can add these up. What is this? This is 225a squared, which is equal to h squared. And then we're looking for h squared, so I'll take the square root of both sides. So h will be plus or minus the square root of, this will be, so the square root of 225 is 15, and the square root of a squared is a. Okay, so plus or minus 15. Oh, great, this is awesome. We were about to have a problem, but then I noticed this. Assume that a is a positive number. Okay, so that means we are in this quadrant. That's super, super important. We are in quadrant 3. So I know that the sign is negative in quadrant 3. Okay, so it's going to be negative 15a. Well, actually, it's going to be negative 15a. I'm sorry, the opposite. So opposite is 9a. So negative 9a over the hypotenuse, 15a. And I don't know if, like, this 15a thing, like, it doesn't matter if it's positive or negative. You know that sine is negative. So this is going to be what it is. Now we just reduce the fraction. This is negative 3a. So this is negative 3a over 5a, which is negative 3 over 5. Okay. So we're going to do the same process for all of these. So the cosine is going to be the adjacent over the hypotenuse. So we'll get cosine of whatever that angle is equal to negative 12a over 15a. And we know that cosine is negative there as well. So I'm just going to make this thing negative. This cancels. We can cancel a 3 out of there as well. This becomes negative 4 over 5. And then tangent is the sine over the cosine, so that makes this really easy. So we'll take negative 3/5 divided by negative 4/5, and the tangent is positive in the third quadrant, so this makes sense. These 5's cancel, and we're just left with 3/4. And then we can figure out the cosecant is the reciprocal of the sine, so we'll flip negative 3/5, we'll get negative 5/3. The secant is the reciprocal of the cosine, so we'll get negative 5/4. It's a 3. And the cotangent is the reciprocal of the tangent, so we'll get 4/3. It's also positive. So yeah, you just have to kind of like make up a triangle, and don't worry about a. Like, just don't even worry about it. It's just a factor in a multiplication. Okay. All right, so okay, this is interesting. So we got some playbacks. We have one really strong going concurrent viewer here. Whoever you are, thank you for watching. It means a lot to me. And we're cooking with gas. We're gonna just keep moving through these. Okay. Sure that was this one. Let me just check. Yeah, that was it. And then go to the next one. We may end up finishing this. I don't want to stream forever, but oof, a lot of problems left. Okay, in the following diagram, angle theta is in standard position. In each case, find sine theta, cosine theta, and tangent theta. Okay, so we can, since they give us a scale here, we can kind of look and see that this, if we just go straight across here, goes to 6, and this goes to -7. So the coordinates of this point are -7, 6. And we can actually just use that to make a triangle here. Make a nice right triangle. and do some trig to this triangle. So the opposite side will be the x, so that's -7, and then the adjacent is 6. Actually, let me thinking through that clearly. Which angle do I want to do? So yes. No. Let me think about this. So I'm questioning which side is the opposite, which side is the adjacent. That's kind of what's going through my mind right now. So let's think about the unit circle. Take this point here. And this is -√2 over 2, 2 over 2. And so the adjacent is, okay, you know, that's maybe not even a good way to think about it. We should think about it in terms of x and y. There's like two definitions for the trig functions. One comes off the unit circle and the other one comes off of like any right triangle. But I think actually the unit circle definition is a lot better. So sine of theta equals y over r, and then cosine of theta equals x over r. These are like the better definitions, and they avoid confusion like that. Okay, so we need to figure out the radius of this triangle then. We can use the points or coordinates here to actually figure this out. So we've got 6, and what is this, -7. So the radius, r, is equal to 6 squared plus -7 squared. I think that's our radius squared. And so we've got 36 plus 49 equals r squared. And this is what, 70, 85? So r squared equals 85. So we take the square root of both sides. R equals plus or minus, let's see, so this will be 17 times 5. So this is actually, we can't really reduce this, √85. Okay, so that's √85. And then what are we going to do here? So the sine theta equals y over r, and our y value for this point is 6, and our r is √85. So before we enter this, we want to rationalize it. So I'm going to multiply by √85 over √85. And we get 6 √85 over 85. 85 has factors of 5 and 17. So this does no canceling. So this is the answer for sine. So 6 √85 over 5. And then cosine of theta equals x over r, which is equal to 7 over √85. And we'll go through the same process of rationalizing this. And we get -7 √85 over 85. And 17 and 5 are the factors, so you can't cancel there. This is 7 √85 over 85. And then the tangent of theta is defined to be y over x. which is 6 over negative 7, which, you just enter this as negative 6 over 7. Yeah. Clear as mud. See any questions, so we'll just leave it. Actually, I guess I should give you guys some time to respond. All one of my concurrent viewers. The chat rate is 0. Help me fix the chat rate. Especially if you have like some like suggestions on how to be a better streamer. That actually I think would be the most useful thing that you could do for me. I don't actually like consume very much YouTube stuff. A couple of channels, but they're all like math related, and I don't really know like what makes it good. Oh, so this problem is like not actually easy to interpret. I kind of looked through these really quickly. I broke this into 2 screenshots just to make it easier on myself. Oops, we don't want to do that. Let me undo that. And delete these layers. Then I'm gonna do this. And re-import this guy. Okay. And then I think Control T does it. Yeah. All right. Let's go there. All right. So the first part of the question is this like graph thing. It says draw the following angle in standard position. I don't know if this is visible to y'all, but the following angle is 0 degrees. And then these 4 graphs are like multiple choice options to choose a graph. Well, the graph in standard position of 0 degrees is this fella right here. That's him. Which is just, I don't know. I really don't like this website. If they want to work on that, just send me an email. All right, so find a point on the terminal side. Okay, so the point on the terminal side of this angle. Okay, yeah, this is kind of confusing, right? Like a point on the terminal side is going to be any point on the positive x-axis. Let's use the one that's on the unit circle, since they probably mean that, even if they haven't written that. Let me try and... That's bad. Okay, let's see if that works. Sorry. And I can't see my cursor unless it's like a certain size. But if it's a certain size, it's obnoxious to write. So, all right, find a point on the terminal. So let's say 1, 0. And don't enter the parentheses because they're actually out here. Find the sine, cosine, and tangent. So if you know your unit circle, these things are very quick. You actually know these. The sine is the y, 0. And the cosine is the x, which is 1. And the tangent is the sine divided by the cosine, which is also 0. So this problem's like a super quick hitter if you know your unit circle. Okay. Okay. There you go. All right. So to the next one. And I think this one's a similar problem. Yeah. Yeah. Next one. Okay. I know like dead air is probably not good to have on these streams, but I just can't do it any faster than that. Okay. And let me clear these. All right, so draw the following angle in standard position. So this is negative 135. Actually, it looks like my student was able to find the answer correctly, so they've already got it picked. So we can go from here to negative 90, and then 45 degrees more gets us to 35. So negative 90 minus 45 equals 35. And that's kind of how I chop this up so that I don't get confused whenever I'm looking at this. I try not to think in degrees ever, but it seems like I prefer radians, but students always prefer degrees since they're more familiar with that. Okay, so a point on this terminal side. Let's just use the point that's on the unit circle, right? X and Y are both negative there, so it's going to be, I'm going to write it outside here. Don't put the parentheses because they are outside of the text box already. This is going to be negative root 2 over 2, comma, negative root 2 over 2. And then we want to find the sine and cosine, so we can actually use these points, right? Those are the values. So it's negative root 2 over 2, negative root 2 over 2, and then sine over cosine is equal to the tangent. So it's actually 1. So another super easy problem. You're able to know your unit circle well. All right, let's delete that. And go to the next one. I'm getting a little bit faster of like switching between these problems, but I think it's a nice opportunity. Maybe I should like queue them all up ahead of time. I think it just take like a lot more work than I'm trying to do. I would like to be able to just have like a nice stream and do much extra editing and things like that, but I don't know if that's realistic. Okay, so it says use definition 1 in figure below. Answer the following. I don't know what definition 1 is. So we'll have to see if we can figure it out. Oh, I don't even know what the options are. Oh, no. Okay. Yeah, I think this one's not gonna, we're not going to be able to do this one, but let's see. So explain why there's no angle theta such that sine of theta equals 2. That's interesting. If sine of theta equals y over r equals 2, then y would have to be blank than r, so greater than r, which is not possible. So I'm willing to bet that this is greater than. And let's think about why that is. So if sine is equal to y over r, so sine of theta equals y over r. So this thing cannot be greater than 1, right? It can't be greater than 1. The reason is because if, let's say y over r is greater than 1. If y over r is greater than 1, I can multiply both sides by r. Now, r should be a positive number, so I don't need to flip my the direction of my inequality here. So multiplying both sides by r gives me this, okay? So that implies if y over r, which is sine of theta, is greater than 1, then y must be greater than r. Now let's go back to our triangle here and see why that doesn't make any sense whatsoever. R is the hypotenuse, okay? So the longest side is r. That's like what it means to be the hypotenuse, or the longest side of a right triangle. So this can't be the case. So the sine and the cosine can never be greater than 1. And when you start looking at the wave function graphs, you can actually see that a little bit more easily. So this drop down is probably greater than. And hopefully that explanation wasn't too long-winded. Okay, let's try the next one. Okay, use definition 1 in the figure below to answer the following question. As theta increases from 0 to 90 degrees, the value of tangent tends towards okay, so tangent of theta equals sine of theta over cosine of theta. And let's ask the same question here, but for sine and cosine individually. So as theta increases from 0 to 90 degrees. Sine, what does it approach? Well, we know what sine of 90 degrees is. Sine of 90 degrees becomes 1 as you get closer and closer to 90. But cosine actually gets closer and closer to 0. And this situation is really, really important to understand. What we're saying here is we're not saying that it becomes 90 degrees. So the angle doesn't become 90 degrees. It gets closer to it, tends toward it. So cosine actually never becomes 0 degrees. It just gets close to 0. Okay, so let's think of a very small number here. Let's put a very, 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 very small number in the denominator. Okay, this when you actually stick this in your calculator or realize that this is tenths, hundredths, thousandths, tens, thousands, hundred thousands, millions, 10 millions, 100 millions, billionths. Okay, did I say that right? Hopefully I said that right. So this is the same as 1 divided by 1 over a billion. A lot of numbers. Okay, then when you multiply by the reciprocal, okay, this ends up being a billion. So the smaller this number gets, the cosine of theta, the smaller the number cosine of theta gets. So as theta gets close to 90, cosine of theta gets closer and closer to 0, but it's still a positive, very tiny number. When you divide by a very tiny number, you get a huge number. So this thing tends towards infinity. I, for some reason, have not had great success explaining this to people. Well, that's not true. I've had a couple of people who didn't quite get this. So I talk about this often in pre-calculus because you're really starting to like tease at the idea of a limit. And that's what this is here. And, you know, this is a hard concept for people. So I would especially like feedback on that, but if this is understandable, then we'll just keep going. Okay. Port. All right, let's make this a little bigger. Okay, indicate the two quadrants theta could terminate in given the value of the trigonometric function. So here you see sine of theta is equal to 7 over 25. That's a positive number. So this is saying which quadrants is sine positive in. I said that the definition of sine is y over r. So here y over r is positive, which means y has to be either positive. Y has to be positive because r is always positive. So the two quadrants where the y coordinate of a point is positive is quadrant 1 and quadrant 2. You remember that from your algebra days. So our y coordinates are positive in these. And that's why cosine is positive in these quadrants, because that's where x is positive. Sine is positive in these quadrants. Tangent is positive here, where they're both positive, or here, where they're both negative. Okay. Maybe we'll get this done. These last ones have been pretty quick. I think this is like a second assignment. So this kind of got split up into two, so we're getting the easy ones again. Indicate the two quadrants where theta could terminate in the given value. Okay, so this is the same kind of problem. Here, cosine is negative. So we're asking ourselves, where is cosine negative? Well, cosine of theta is equal to x over r. R is always positive, so we're asking, where is the x coordinate negative? The x coordinate is negative in these two quadrants, which are quadrant 2 and quadrant 3. Here and here. Okay. Okay. Zoom this in a bit. Okay, indicate the two quadrants theta could terminate in given the value of the trigonometric function. So I kind of prefaced this already. So tangent of theta is equal to sine over the cosine, which reduces to y over x. And so we want this ratio to be positive, okay? So the only way this ratio could be positive is if both y and x are positive, which happens here, or if they're both negative. Negative divided by negative becomes a positive. That happens here. So these two quadrants have tangent negative. I'm sorry, tangent positive, which is quadrant 1, quadrant 3. Okay, indicate the two quadrants theta could terminate in given the value of the trigonometric functions. So, all right. Okay, so here cosecant is negative. So cosecant is the reciprocal of the sine function. So cosecant of theta is equal to 1 over sine theta, which is equal to, instead of y over r, this is r over y. So we need the quadrants where the y is negative. Where's our y coordinate negative? In quadrant 3 and quadrant 4. So these are all not too bad. That is the same problem. Okay. All right, so indicate the quadrants in which the terminal side of theta must lie under the following conditions. Sine is negative and tangent is positive. Okay, so same thing. Sine of theta is equal to y over r. So sine will be negative or y is negative. That happens here, oops, here and here. So this is where sine is negative. Tangent theta equals y over x. And so for tangent to be positive, tangent needs to be positive. That happens where both y and x are positive, which is here, or where both y and x are negative, which is here. And so this is the only one that overlaps. Here sine is negative and tangent is positive. So the only place this can happen is quadrant 3. Okay, we are moving along. This is going much quicker than I anticipated. Okay, let's see. So indicate the quadrants in which the terminal side of theta must lie under the following conditions. Cosecant and cotangent have the same side. Okay, so let's look at this. Cosecant of theta is 1 over the sine of theta, which makes it r over y. And cotangent of theta is the reciprocal of the tangent function, which means instead of y over x, it's x over y. Okay, so these things need to have the same sign. I know that cotangent is positive. Actually, let's make this a different color. Let's make this guy, let's make him blue. All right, so cotangent of theta is, instead of y over x, it's x over y. Okay, so let's think of some coordinate plane here. Where is cosecant positive? So cosecant is positive where y is positive. So it's positive here, and it's positive here. It's negative here, and it's negative here. Then we can do the same question for the cotangent. Where is cotangent positive? Well, it's the same place where tangent is positive. It's where x and y are both positive. or where x and y are both negative. And then obviously where you have different signs, like where x is the opposite sign of y, or vice versa, that's where they're negative. Okay, so what is this asking? It says, where do these things have the same sign? Well, we can see that here they're both positive and here they're both negative. So quadrants 1 and 4 are the answer. 1 and 4. Boom. That. Okay. So find the remaining trigonometric functions of theta based on the given information. Okay, so this is saying cosine of theta is root 3 over 2. Okay, cosine of theta is root 3 over 2. And cosine terminates in quadrant 4. So here's quadrant 4 down here. Cosine is root 3 over 2. That means if let's just be naive about this. I know that it doesn't have to be the case that, so cosine is root 3 over 2. So it's going to be something like this, okay? We can make this little triangle like that. Okay, the ratio of the sides is root 3 over 2. Okay, so the x over the hypotenuse is root 3 over 2. It doesn't have to be the case that the side lengths are root 3 and 2, but their ratio is root 3 over 2. And that's actually, we're going to care about the ratio for all the other 6 functions, so we're going to report them in the reduced fashion anyway. So that doesn't matter. We need to figure out this other side, the y side. So let's use the Pythagorean theorem. Y squared plus root 3 squared equals 2 squared. So y squared equals 3, oh, I'm sorry, y squared plus 3 equals 4. And we'll subtract 1 from both sides. Y squared equals 1. And then we'll take the square root of both sides. And so here we're going to get plus or minus root 1, which is 1. And we know that in this quadrant, the y coordinate of a point is actually negative. So we'll take this to be negative. Okay, so now we've got our 3 sides of this triangle. These may not be the actual 3 sides, but the ratios will be correct. So that's the only thing that matters. So sine is going to be the y over the hypotenuse. So it's going to be negative 1/2. And the tangent is the y over the x. So it's going to be, so tangent of theta is y over x, which is negative 1 over root 3. But we need to actually rationalize this. So I'm going to multiply by root 3 over root 3. And that gives me negative root 3 over 3. So that'll be our answer, negative root 3 over 3. Cosecant is the inverse, or I'm sorry, the reciprocal of sine. Cosecant is the reciprocal of sine. So the cosecant of theta equals the r over y. And so we've got 2 over negative 1, which is negative 2. And the secant is the reciprocal of the cosine, which is cosine that was actually given to us. So actually, oops. Nope. If I redo things in this. Oh, interesting. Okay, so cosecant, what did I say that was? Negative 2. Okay, so the secant of theta is equal to the reciprocal of cosine, which is r over x. And so from our triangle, we get 2 over root 3. We need to rationalize that by multiplying by root 3 over root 3. And so this becomes equal to 2 root 3 over 3. And then the cotangent of theta is equal to, instead of y over x like the tangent is, this is x over y. And so this becomes root 3 over negative 1, which is equal to negative root 3. And that's that. Okay, so same kind of problem. Find the remaining trigonometric functions of theta based on the given information. Okay, so tangent of theta is 8 over 15. So we're going to do the exact same thing we did before. We're going to make coordinate plane here. And then we know that this is in quadrant 3. And this is y over x. So y is less than x, so it's going to be something like that. All right, there it is. And then let's make another triangle. Okay. Okay, so tangent of theta is y over x. And actually both of these coordinates are negative because it's in the third quadrant. Then we can figure out the hypotenuse r using the Pythagorean Theorem. So negative 8 squared plus negative 15 squared equals r squared. And so what is this? This is going to be 64 plus 225 equals r squared. So r squared equals, this would be 289. And then r equals square root of that, which is some unknowable number. Let's see. $17. Okay. All right. Okay, so we found all 3 sides of this triangle. We can use these sides to make our relationship. Okay, so sine is the y over the x. So negative 8 over 17. Cosine is the x over the, sine is the y over the hypotenuse. X is the, cosine is x over the hypotenuse, so negative 15 over 17. Cosecant is the reciprocal of the sine, so it's negative 17 over 8. Secant is the reciprocal of the cosine, so it's negative 17 over 15. And cotangent is the x over the y, so the reciprocal of the tangent. So we're actually going to get 15 over 8. So easy peasy. And let's see what we got here. That's the one we just did. Okay, only 5 more to go. All right, let's go. So the remaining trigonometric functions of theta, beta. So okay, we're gonna same problem. These things get really repetitive, so let's just go through it. So draw ourselves coordinate plane, and so this terminates. Okay, so it says cosine is less than 0. That means cosine is negative. That means it's going to be in one of these 2 quadrants. And then I also have the cosecant positive. Cosecant is 1 over the sine. So if cosecant is positive, sine is positive. Sine is positive up here, and cosine is negative here, so I know I'm going to be in the second quadrant. And then this is, cosecant is the reciprocal of the sine function, so this is r over y. So let's just make it like this. Okay, r over y. And then we'll do another one like that. Okay, so r over y. So 25 y, which means 7. And then we need to find this x, so we can use the Pythagorean theorem here. X squared plus 7 squared equals 25 squared. So this is x squared plus 49 equals 400, 500, 625, 625. And then so squared equals 576. And I have no idea what the square root of that is. This is so 3 times 8 is 24, so 24 squared. Yeah, 24 squared. Okay, so this is 24. All right, and actually, let me write this is plus or minus the square root of 576, which is 24. And since we know the x coordinate is negative in the second quadrant, I actually know that this is a negative number. This negative 24. So x is negative in the second quadrant. Okay, now we just use these values and figure out our sine, or figure out our trig functions. So the sine is the y over the r, so 7 over 25. Cosine is the x over the r, negative 4 over 25. Tangent is the y over the x, so negative 7 over 24. Secant is the r over the x, so negative 25 over 24. And cotangent is the x over the y, which is negative 4 over 7. And it's good to have those definitions handy somewhere, like make yourself a cheat sheet, you know, sine theta is y over r, cosine theta is x over r, tangent theta is y over x. This is cosecant, the reciprocal of sine, is r over y. Secant theta is r over x, and cotangent theta is x over y. So, you know, pause this, write those down. You can find these on the internet. Make yourself a cheat sheet, stick it on the wall behind wherever you do your homework, put it in your notebook, wherever. This is a good thing to keep a reference of. Like, after you've looked these up a bunch of times, you'll end up memorizing them. And really, you only need to like memorize these ones, and then these are the reciprocals of those, right? So you can see, I just took this and flipped it to get this. I took this and flipped it to get this. I took this and flipped it to get this. Okay. So we did that one. All right, okay, so same problem. These get really boring after a while. Okay. Okay, Okay, all right, this is actually interesting. Okay, so same thing. So m and n are, all right. Find the remaining trigonometric functions of theta based on the given information. So it says cotangent of theta is m divided by n, where m and n are both positive. Okay, so m and n are both positive. That means that we are somewhere in the first quadrant. So we're somewhere in the first quadrant, and we can do the same situation here. Cotangent is the x over the y. And so we can use the Pythagorean theorem to find the other side. M squared plus n squared equals the radius squared. We'll call it radius. And then solve for the radius, you just take the square root of both sides. So we do plus or minus the square root of m squared plus n squared. Now we're just going to take the positive because it's a distance in this case. This is m squared plus n squared. Okay, so with that we can actually do this. So sine is the y over the hypotenuse. And you know, I think that they would actually want you to rationalize this. So sine of theta equals y over r, which means that we got n over the square root of m squared plus n squared. And we actually need to rationalize this. So let's do m squared plus n squared over m squared plus n squared. And this becomes n times the square root of m squared plus n squared over m squared plus n squared. And that's simplified. You can't do anything else with that. So n m squared plus n squared over m squared plus n squared. Now, for the rest of these, I'm going to rationalize them, but I'm just going to do it very quickly. I'm going to assume that you know how to do this, unless someone posts a comment or a chat message about it. Okay, so cosine is the same thing, but it's with m instead. So this just becomes m times the square root m squared plus n squared over m squared plus n squared. Tangent is y over x, so it's n over m. Cosecant is the reciprocal of the sine, so it's the hypotenuse over the y. And secant is the reciprocal of the cosine. It's the hypotenuse over the x. Yeah, that one's cool. Okay. Find sine and cosine if the terminal side of theta lies along the line y equals to x. Oh, okay. In quadrant 1. So we got to remember, we got to remember how to graph lines. That's kind of like a big part of this. So this is in slope-intercept form, y equals mx plus b. And if this is in slope-intercept form, you can see that 2 is times x, so that's the slope. So slope is 2, and b is the intercept. There is no b, which means b is 0. So they said, and I'm just going to kind of like estimate the slope. There's no scale here, so my slope is perfect. Okay. So let's choose a point on this line. All right, so here's a point on this line. Let's say this is my x coordinate. I'm going to call it A. So if I plug in x equals a into my equation, I find that y is equal to 2 times a. This is 2a. So this is the point a comma 2a. And this will be every point on the line. Like, you just put whatever a you want, and that'll give you the other, the y coordinate, which is 2a. So we can use these two values to find sine and cosine. Let's imagine this is a triangle. That is not my dog. Somebody else's dog. Just can hear that.